maybe aren't familiar with modular JavaScript at all, or what even that means. So I'll cover a bit of that, but also I've hopefully got some kind of slightly more meaty, juicy stuff for you guys that actually already know about it, so that I'm not entirely preaching to the converted pointlessly. So a little bit about myself. This is me. I think I'm aged 11 there, but this is before you had time-coded cameras and stuff. So something around that age. And as you can see, I was kind of big into my tech. I've got a Casio keyboard. So that's how I became what I am now. And these are some of the things that I'm interested in or that I do in my job. My job definitely focuses a lot on best practice because half of my role is kind of about leadership and understanding what the industry does and making sense of that and feeding that into my team. I've also got kind of a little personal obsession with web accessibility. I think we should all be making products that can be used by anyone. And for the keen-eyed of you out there, you might notice that actually I've got gardening in there. It's true, amongst all those other amazing and esoteric things, I do actually have an allotment. So yeah, I work at a company called Zone. We are a full-service agency. We have offices in London, Bristol, and now Cologne. And weirdly enough, as of tomorrow, I'll have been there for 4 years. So this is something of an anniversary. So without further ado, yeah, what I want to explain is a little bit about what it is, what modular JavaScript is, and why you would switch to it if you don't use it already. A little bit about what the actual APIs are that are out there that you can use. What tools you can use to actually make it happen. And some of the ways we actually go about where I work implementing it, because it can be a bit of a minefield. So what exactly is it? Well, let's maybe start just by looking at the actual goals. All of the kind of APIs that have been produced over the last, 5 or 6 years have kind of got similar goals. So yeah, to encapsulate code. There was a good talk last time actually about CSS modules, and that was, one of the big pluses of that was encapsulation and having logically organized files in a similar way to other languages. Other languages obviously had this approach for quite some time. Also, defining dependencies that must load before a module is executed. That's really, really important and one of the massive persuading factors for switching to this. So essentially, you are ensuring that you don't have that ridiculous situation where you have a script tag somewhere on the page and jQuery loading as the JavaScript runtime or the browser sees fit, and then another bit of code which relies on it maybe not loading and actually having access to that. So this whole structure is to avoid that silliness. And finally, to load smaller, more manageable files and only load them when needed, which some of the things I'm going to talk about later in the talk do better than others. What it actually really is, it's a design pattern. So, I suppose in lots of industries where you make things, you have different patterns, different approaches to it. Imagine in engineering and some of the industries you have different ways of organizing things so that you can reuse them. So a sort of quick example of the kind of things I'm going to dip into are, having multiple files that are maybe, if you decide so, organized in such a way that you control them with one single file. There are other patterns, more complex ones. But the whole idea of it, I guess, in a way, is to reduce complexity. And as nice old Brian Kernighan said, controlling complexity is the essence of computer programming. And if you kind of wrote Unix, you probably know what you're talking about. So this is how it used to be for us. When I started at Zone, it was very much like this. So we had one awful, horrendous, single, ginormous file of like thousands of lines of code in it, and no dependency management, poor ordering. If you could be asked, you might move some functions around to kind of group them with their buddies, but generally no one could be asked or didn't have the time. You had really weird close coupling, and you had loads of merge conflicts, because obviously if you have lots of big files with lots of lines of code, Git or whatever it is you use, so version control is going to have a nightmare actually making sense of all that if you have lots of devs working on the same file. So it was kind of like this for us. you'd look at a file and, what? You couldn't make any sense of it. And now, it's considerably better. So we might have on maybe a medium-sized sort of CMS-driven project, 30 smaller files. We have complete dependency control. So, any third-party plugins, any frameworks, any libraries we're using are only required when necessary. We have loads less repetition. Like I used to look through, when I was tech leading on a couple of projects, I used to look through the code that we produced in our ginormous single files. And actually, you sometimes find the same function doing the same thing because one dev would have written it and happily got it working. Another dev wouldn't know that it existed and happily got it working. And so it goes on. And consequently, fewer bugs and fewer merge conflicts. But just to point out, with all these approaches, you have a little overhead, and I'll come to why that is later. So now we've got a nice, nice warm feeling when we work with each other. That's me. So just to back it up with some evidence, you should always have a slide like this, I think, in a presentation that's about, really full-on vertical tech stuff. Numbers, yay, numbers sell stuff. So Stack Overflow, absolutely tons of results for people probably having loads of headaches with modular JavaScript. Loads of GitHub repos, loads of people have tried to solve the same problem, which is great. And loads of Google results. If you Google it, that's an astonishing number of results, 500,000. I guess maybe some of it is kind of porn, spam or stuff, but it's a good number. And as a consequence, thousands of happy devs. And we've used this approach on loads of projects, so it's just a handful of the clients that we work with. It definitely saved our bacon in a couple of circumstances. So the work we did for Tesco and RSBB more recently has really benefited from us being really organized and taking this approach. So for those of you that haven't adopted it already, and I'm guessing some of you have, in fact, let's do a quick poll. So hands up if you use a modular JavaScript approach. Okay, so yeah, just over half. So I'll skip this bit then. No, joking. This is why you would do it. This is, I would say. You're going to get more manageable code. You're going to be able to separate concerns more easily. One advantage that is probably a bit underrated, but we've all had headaches with, is you protect the namespace. So not everything in the whole world is hanging off the window and possibly fighting with other things. And you can leverage open source packages more easily. I'll come to that in a bit, but essentially it's about kind of using things like NPM or other ecosystems that exist out there. And you can do lazy loading, and I'll come to that shortly as well too. So if you had to sell it to your colleagues for any reason, or your boss, maybe they're particularly stubborn, I don't know. But you can definitely make the case that you're going to have a lot more easy onboarding and handovers with other team members. More easily have parallel work streams, because one person can work on one module or one feature, which could be a module, and another person on another. Therefore, you get more easy application maintenance. And yeah, you get less errors, and debugging is kind of easier because you're able to focus on the problems that exist in one small area. So in one phrase, that would be the sell. It's basically an investment. If you haven't got a boilerplate or something that is configured like this, put a bit of time in, make it work, and reap the benefits. So the landscape, this is the bit that fried my head when I was putting it together, I have to say, because there is quite a big landscape out there. However, I'm going to start off gently. So the first thing I think that is worth pointing out is that before we kind of go into any of the major APIs, there is a pattern that's been around for ages, which Adi Osmani has done a great job of documenting, which is called the revealing module pattern. And it's not necessarily, it's not quintessentially modular JavaScript, but it's just a way of thinking about JavaScript. So if we have a quick look at some code, I know that's a bit scary, but essentially you can have a module, which is just a self-calling function, and some things in it. They could be objects, they could be functions, they could be properties, and you decide what it is you want to return. I'm kind of undoing myself with my own shadow. It's a bit annoying. And when you actually want to run it, you've decided what you've revealed or not, and you can call it. So one of them isn't going to work, and one of them is. And you can obviously have things that run privately, things that happen when you've loaded that module. But it's just a really, really simple idea. It's a really elegant idea that you just encapsulate something and you decide what you make private and make public. And early on in, I guess, the thinking about JavaScript patterns, a group formed who were previously called Server.js and have since become CommonJS. Now, they created a pattern. They actually wanted this to be the kind of the tonic for lots of JavaScript programming woes, and they were hoping, I think, that the industry and maybe even JavaScript itself would adopt their ideas, and maybe in a funny kind of way it did. But they came up with this idea, and it was kind of really, I guess, born out of server-side JavaScript, so Node, essentially. And it's really, really nice and clean to look at and really simple to use. It doesn't have any kind of wrapping function or anything. You can just decide what dependencies you list and decide what things you export as a module. Funnily enough, it does actually work synchronously. So if in a weird situation you were loading a module which it could get but was going to take time to acquire, it would actually completely stop the browser from working temporarily while it was thinking about that. But it's the whole sort of premise of CommonJS is it's about having a short distance, so all the files that you're using are in your application and are easily accessible, and therefore you don't really have a problem with that. You won't notice it. There is a little bit of an example of CommonJS. So as you can see, you don't need anything kind of wrapping anything else. You can just decide what it is that you attach to this module object, which it gives you. You know, it can just be a calculation. It could be another function. And yeah, it's really, really clean and straightforward and very nice. And then shortly after that came along AMD, which at the time seemed like the most wonderful thing in the world, I guess. We certainly thought it was. And the whole idea of this was, rather than the CommonJS approach, which is kind of about the server, this is about giving something to front-end devs, you know, people that work in the client, in the browser, and designing a system that's not blocking. So when you request access to another module, it goes and gets it asynchronously. So it basically sort of puts the phone down and walks away and goes and watches the TV for a bit and then comes back and says, your module is ready now, but it hasn't broken anything in your app, which is really nice, or can be really nice. But speaking of wrapping functions, it uses this define wrapper, and yeah, that has its pluses and minuses. It's a bit ugly maybe, and it's more verbose, so you have to list the things you want to load, and then you have to list the things that you might get back if those things return something. So obviously I'm using jQuery here and I get back $1 and then I can use it. And yeah, it can get pretty messy. We had some really, really fun times with the AMD approach. So even though this talk isn't supposed to have too much opinion in it, you're probably going to get some. You know, I'm over this now. I'm over it. And I had to sort of shoehorn this in because I think this is a really interesting example of, I guess, how weird the landscape is. So someone cooked up this idea that, okay, we want to be able to publish modules that use AMD and CJS and actually jQuery plugins, and it goes on and on. And so they made this amazing thing called the UMD Wrapper, which you can throw in the top of your module, and it's only really, really small and concise like this and really easy to configure. Wow. I actually contributed to a library recently where I had to add this, and it so wasn't fun. And the real gotcha is that if it uses a node-style thing, like a CommonJS kind of thing, then all these paths will probably work because things like moment.js or ES6 promises may exist on NPM, and that's great because it will just go and find it. It'll look it up by its name. But if it's AMD, it probably won't know where it is unless you've told it so. So you have to configure these paths yourselves. And anyway, it served a purpose. It still serves a purpose. But as Scott Andrews says, it's not a lie. I mean, no one said it was a lie, right? But anyway, it's not a lie. It works, but it is a compromise. He is actually the author of curl.js, which is a library a bit like require, which I'm sadly not going to feature in this talk, so apologies, Scott. So yeah, here we go. I don't know, it's the slide everyone was waiting for probably. It's the one I'm so excited to deliver. ES6 modules. I mean, ES6 is the panacea for everything, right? I mean, yay, ES6? Oh, someone's shaking their head. Okay, well, I'm going to go with it anyway. It's good for certain things, right? But it's got a way to go. So yeah, because of the proliferation of these APIs and because I guess they're kind of managed by different groups and non-standard, yeah, JavaScript adopted it. So it's actually an official part of the spec now, even though almost no browser actually fully can implement it yet. But it's designed for the browser and the server, which is really, really nice. So it kind of caters for both of those worlds. And the wrapping that I mentioned, it's implicit, so you don't need to do anything too fancy. It's really, really concise, I suppose, and kind of pretty to look at. There's lots and lots of really lovely ways that you can import and export. You can do multiple things at once. You can rename modules just using one line. And I won't go too much into it because I'm probably eating into my own time enthusing about it. But yeah, it's pretty smart. So just to summarize this bit, AMD uses this kind of require and define paradigm, and it actually does also support module exports and exports. So you can actually, with require and with AMD environments, you can actually also write in the CJS style. I don't know if anyone's done that or had much fun doing that, but I can't imagine it's particularly great. CJS uses require and this export, well, this module object. And ES6 just has a very simple import and export. Interestingly, though, it does also have a system import, which, again, I don't think it's implemented that well, but there are polyfills for it. And it basically means using promises. You can load other modules, so you can do nice asynchronous stuff. And yeah, conversion. So yeah, I really, really, it pains me to think of anyone who's had to do this. Convert from AMD to CJS, you can do it. There's a couple of decent libraries on GitHub. I can't imagine it's much fun. And you can go the other way as well. So you can go from CJS to AMD, which I believe SoundCloud had to do. So they had loads of legacy code and they had to convert it. So they used a library called Sweet.js to do it. You can convert from ES6 to AMD and CJS. Confused? Okay, good. Which is kind of getting to the nub of the talk in a way, because this approach is what we actually take and is working really well for us using the lovely Babel transpiler. So let's have a quick look at the loaders. So first up, require, which largely uses the AMD pattern, but as I say, you can also do CJS. And the nice thing about require maybe is that it runs in the browser, so you basically you can write a module and save it, and it will manage it for you. There's no build step, and it can lazy load things. So let's say you've got an application where you've got loads of libraries on one page. You've got D3 and, I don't know, P5 and loads of Canvas stuff, loads of fancy stuff going on. You can just load the modules that you want for that page without having to do any fancy bundling. And it's now got some pretty decent community support because it's been around for a while. The cons for using it, the error logging is terrible. If for some reason you've got one single name wrong for a module, it's not going to tell you that. You're going to basically, if you use it for long enough, you kind of get used to these weird errors, and you eventually figure out what they mean, or you make educated guesses. But that's not fun. And the caching problems, this is a really weird one for me. Even if you've got DevTools open and you refresh, it still doesn't necessarily always give you your new code, which is horrible. The documentation, so awful. In fact, I'm going to stop there. I'm just moaning. So yeah, one thing you've got to watch out for if you're using it is this order, the order of the things that you're loading, and the order of the callback, the objects you're getting back in your callback, they have to be absolutely correct. If this structured data was before base, game over. So just one to watch out for there. Next up, Browserify, which is basically born out of Node. So, I mean, to check out that logo, what a stinker. Horrible. I don't know what they were thinking, but And it's just nothing to do with Node, is it? It's not even, Anyway, so yeah, with CommonJS, someone saw the need to bring all that Node loveliness into the browser, and so they came up with Browserify, which basically allows you to take advantage of NPM and all the Node modules that are out there in that ecosystem. So pros for Browserify, as I said earlier, simple syntax. You do get some sensible errors. It's got really, really nice documentation if you can overlook the branding. And with the help of Babelify, which is like a nice little plugin, you can write in ES6 and it will spit out CJS for you. So yeah, one small downside, I suppose, is there's a build step, but then I suppose lots of front-end or devs in general are using task managers and stuff to do build steps, so it's maybe not a big deal. Yeah, if you want to output multiple bundles, it's a bit more of a headache. And it only supports CJS, and as I said earlier, it's synchronous, which could be a downside, but I've not had a problem with it. Yeah, just to reiterate, whew, awful. Yeah, gotchas. I suppose the only gotcha really is that, and this is just a general Node gotcha, is that what an actual NPM module returns varies wildly. So if you're using this nice handy ES6 promise polyfill, you've actually got to, actually attach it to that particular property. Some things don't actually return anything at all, which I suppose happens in other situations. But I've definitely had some NPM weirdness or Node module weirdness. Next up, Webpack, which is by far the most powerful of all of them, I would say. Supports AMD and CJS. It's really easy to create multiple bundles, which kind of ameliorates the problem of not being able to do lazy loading so well. It's got a massive set of features, so you can kind of process images in it and do all sorts of fancy stuff. Documentation's really, really good. Logo's okay. Ships with its own server, which is pretty nifty. It's basically trying to take over the world, really. It's completely comprehensive. It's amazing. And I sort of struggle for some cons. I suppose it's quite a lot of faff to configure, and there's a bit of a steep learning curve because you've got so much power, and it's not very prescriptive. Browserify does a very sort of single-purpose thing, whereas Webpack kind of, as I say, tries to do too much. And just quickly, JSPM, which is kind of a new kid on the block. This has its own registry. I'm going to leap to that point because it's a really interesting one. So you can just sort of say JSPM install jQuery, and it will go and get it. It'll look it up. And it supports all the different patterns there are, but you have to pick one. So that's one of the cons I've included, that you actually have to pick an API. You can't mix them. In Webpack, you can, which is really interesting. And the community is quite small, and some of the plugins aren't very mature. So really nice idea, JSPM, but I'm not sold on it personally. As I say, no opinion whatsoever. So how do we actually implement this? So I think the most important things to assess first are the performance of the actual product you're making, the maintainability and the scale. So if it's a really small project, then I suppose there's no reason to throw all the big tools at it. You could just go for the most simple and straightforward scaffolded project. That's not to say you shouldn't use modular JavaScript. I'm just saying that you might not need Webpack or something as heavy as that. But it depends entirely on what you want to achieve. And the shape of your team, I think, is important as well. Okay, if you're a freelancer, then perhaps this doesn't matter so much. If you're not going to have to hand the code over to someone else, perhaps it doesn't matter so much. But what I've found is every time we've made a new step forward, or what feels like forward, where we've adopted a new strategy to building websites and to making our code more maintainable, that we've obviously got to educate the less experienced people in the team. And some of the concepts in here and some of the products like what require, for example, we start out great documentation. They're going to take more of your time. If you're the person who's in charge of educating other people, you're going to have to really put the hours in and put the effort in to make sure everyone's up to scratch. And you're probably going to have to sit with them occasionally and do some really grim debugging. So yeah, make the time for the education. The nature of the app itself. So if you're using a framework like React or something, then it kind of starts to decouple lots of the scripts and the views and things anyway, and it's got its own way of tackling, I guess, some of the goals which this subject does. Yeah, and if the application shares code on the server and on the client, then it's maybe worth just picking a common JS approach because it's kind of designed for the server and can work in the browser. And if the project is going to be around for a long, long time, could argue that you should use ES6, not just for modular JavaScript, but for everything. Any shaking heads out there this time? Maybe not. But yeah, if you want to future-proof it, then that's the direction that everyone is seemingly going in, although I appreciate there's some effort that goes with that because you have to transpile down to something that browsers can understand. So here's just a quick diagram, simple diagram of how you might manage a site, how you might do bundling. You could have a bunch of things which go into 2 different modules, which are then only rendered on the home page, and you can sort of decide on the architecture yourself. As I say, the easiest thing I found for doing this is either Require or Webpack. Browserify does do it, but it's a bit more faff. And the tools that you can use to actually compile and concatenate all these things together, and they do need to compile because even with CJS, you need something which is going to tell the browser how to actually work with it. So Gulp and Grunt are the 2 obvious task managers, but you can, if you want to, use some of your colleagues' server-side applications. I personally wouldn't, but no opinion. So the way we do it at Zone is all modules are discrete pieces of functionality. They are sometimes a sort of trackable feature, in a project management sense. Sometimes there's more than one module that belongs to that particular feature. In the browser, that is, they always run based on the presence of a data attribute, so we kind of don't use CSS classes or anything like that. We keep it just to using data attributes for decoupling. And we use source maps, so with Gulp and Grunt, you can create a map of all the modules that you are writing in, so that when it actually renders one bundle or one big file, you still know what you're looking at. If there's a bit more time, I could have shown a nice little screen grab of that, but you just have to use your imagination, sorry. And headaches, of course, with these things are always headaches. So lots of times we've had problems incorporating third-party scripts. So you might need a shim, or you might need to actually wrap it yourself in that UMD wrapper or something to make it work properly, because not everything that's published on the internet, funnily enough, works with everything else. And keeping a large project organized takes a bit of effort. So consider things like naming conventions and how you structure your folders. And yeah, one last little tip, handling data. So each module is obviously encapsulated, so you need to think about how you're going to share things that happen, user actions. And we use PubSub, which is a way of listening for particular events. You can use jQuery to do that too. And we use promises for asynchronous stuff. And we completely avoid using callbacks as much as possible. So this is our stack. So we write in ES6 as much as possible. We use Gulp to manage most of our tasks. We use Browserify/Babelify to convert from ES6 to CommonJS, and it works in the browser. And this is what we're kind of moving to. So we're going to adopt Webpack. And I'm sorry that was almost half an hour. Big subject, though. So thanks a lot.